Aloha, Richard Halverson here. This is ICS321, and today is February 2nd. And let me share my screen. Yeah, well, 321. And we are in this week 4. And so we're working on video number 4 today. Um, so it turns out that the video, or see, last week I did chapter 2, and I did a miserable job on section 2.8. So actually, today what I'm going to do is I'm going to go over some important sections, some important stuff in the last 3 sections of chapter 2, and then I'm going to this is today, and then on Friday I'll have another ICS 321 where I will attack chapter 3. Okay, and so one thing I wanted to point out is I want you to make sure you put this up here, pop out the chat just in case anybody wants to say anything. So make sure you go here and you fill in. Let's see if I think I've updated this a little bit. And I've just decided to add, I added a 9:30 slot, and these are all the possible times, Monday through Friday, that I would really like to keep the classes scheduled. And so, but there's some Mondays I can't do it. Sometimes on Wednesdays I can't do it. Like tomorrow for Wednesday, tomorrow for example, I can't meet at all in the morning. But and I'll leave those up to me. And but then when you go to this cansit.in website here that I cleverly created, I will always have the week's schedule here like this. Okay, so so you can come here anytime to be reminded. Cansit.in, and see when the class is. But also what you can do is you see these times when there's no class. Those are fine times for office hours. So if you need to have a question, something quick, something not so quick, you want me to explain something to you, you can just like email me or text me sometime and say, hey, do you have time? And I'll probably yes, because I'll just be sitting here at my desk. I'm not going anywhere. So that way we can meet, we can do a Zoom. So anyway, so let's go to, I was covering chapter, or we're doing chapter 2, and chapter 2 is a pretty important chapter. These joins are pretty important things to know how to do, and there's all these different kinds of joins. So it's helpful to go through and make sure that you understand how you can connect 2 tables together to create a larger table or a larger data set which combines columns in various ways, because you want to store your data in the most reduced highest normal form there is, and that's what section 2.8 is, because then you have the best chance of there not being any kind of redundancy in there, which can cause problems. And if there's redundancy in your database, when it comes time to update the database, then you can run into integrity problems, ambiguity, and so on. So so when you're joining 2 tables, a inner join is okay. So you're always joining 2 tables on some column. Okay, so in this case we have a department and an employee, and here we're joining. It's not obvious, but what we're joining is the department manager is an employee, so this manager is actually an employee ID. See, so this is really the same type uh, as this, is this one here. And so when you're joining, you're matching up rows from each where these numbers are the same, where the keys or the this here is a primary key in this table. In this here is a foreign key in this table. This here is the primary key of this table. So this engineering 2538 and 2538 and Lisa Ellison and salary and code and so on, they are all related, obviously, and they were joined based on this foreign key and primary key. And when you're joining, you're matching all these things up. Okay, so there's basically 4 kinds of joins, because what happens when you have a field value on one side but you don't have it on the other side? Okay, well, that can be two ways. You can have one on the left table, but it doesn't exist at all on the right table, or you can have one on the right table that doesn't exist at all on the left table. And when you're doing joins, for an inner join, they both have to be there before the result of your join, the table that's the result, the rows that are included. For a left join, all of the rows of the table on the left are there, and those that match on the right are matched. But if there's no match on the right, then the record on the left still is there. And for right, it's the opposite of left. All of the records on the right are all there, and even if there is not a match on the left. And then for full join, if there's a blank on the left, that's fine. If there's a blank on the right, that's fine. So here, let's see, does this thing show the differences? Okay, this looks like an inner join, because the only records that are here are the engineering Lisa Ellison, which is this Lisa Ellison, the sales Maria, and the marketing Maria. The technical support is not here. You don't see technical support here because there is no null, or there's no manager. There's no employee here. On the right, you have Sam Sneed, who's got an ID, but there's no department on the left that's got a manager of 3484. So Sam Sneed doesn't match anybody on the left. Sam Sneed doesn't match anybody on the left, and technical support doesn't match anybody on the right. So an inner join has neither. A full join has both. It's got both Sam Sneed and technical support. A left join would have technical support, but would not have Sam Sneed. That'd be a left join. And a right join would have Sam Sneed, but would not have technical support. See, so a right join would have this record here, this Sam Sneed record, but would not have the technical support record. Anyway, so those are joins. Joins are important. Left joins and right joins, and you have to know when to use them and so on. Okay, so that's important. And then there are these things called views, and views are nice because you see, when you do a select statement, you're actually producing a table, okay? And a select statement is you're doing you're saying a projection, the columns you want out of there, and then you're saying what the table is that you want the columns out of, And then you're saying, then you're restricting the rows, okay? So that's what a select statement is all about. And what the select statement produces is something that looks exactly like a table. It looks so much like a table that it can be used in place of a table. Okay, that's closure. Okay? And so here we're selecting something from a table. Well, instead of having this thing there, we could have another select statement inside there, parentheses. And you can have selects inside selects. Okay. Well, view is kind of like an intermediate step where we create this thing called a view, and that produces a table. And so you can treat the view just exactly like a table. Um, and you can use it as a table, but really it's a select statement. And when you use a view, you're actually causing a select statement to execute every time. And of course, what that means is that tables that are the tables of that select statement of that view, they can change, and then of course then the view changes. So anyway, that's views, and that's important. But what I really want to do this time is go over normal forms again, because I think they're really important, because they are the way that if you're good at reducing your tables, your database down to the level of normal forms, the right level of normal forms, then you'll save a lot of kinds of integrity problems that your database can have in the future. Okay, so uh, redundancy. Okay, so a database. Okay, in a database, a fact is a pair of related values, and redundancy would be repetition. So a fact is like, um, you know, passenger Elvira Yin is passenger number 222. That's a fact. Elvira Lin is flying on AZ312. That's a fact. Okay. Redundancy is the fact that you have Elvira Lin. You have Elvira Lin more than once. You have the fact that Elvira Lin is 222 is repeated 3 times here, simply because Elvira Lin is taking three flights. Okay, that are in this booking table. So that's and what normal forms is it's continually breaking up single tables into multiple smaller tables, continuing to do that um, all the way down to you may have just a whole bunch of tables with each only have 2 columns, with these single facts, and after that they're all related and connected up based on primary keys and foreign keys. Okay, and so you really want to kind of break it down as far down as you can go, and then you put it all back together again by using joins and nesting selects inside of selects and so on, or creating views. So here, so here that we're talking about there's different stages, and this textbook talks about first, second, third, and Boyce Codd, and then the homework assignments actually have a 4th normal and a 5th normal form, 4th normal, 5th normal form example, and this book kind of doesn't think 4th normal form or 4th and 5th are that important, but we will see in some contexts, they're kind of very important. So we'll see those. And then there are actually some higher normal forms in that, but they are kind of crazy. The database academics kind of get into that. Here it makes sure you understand the concept of redundancy and facts, and the fact that the levels of the normal form. Redundancy is a repetition of a value. No, it's a repetition of a fact. is false. It's repetition of, no, it's false because it's repetition of effect. Third normal form allows fewer types of redundancy. In second normal form, yes, it's true. Less redundancy. The higher the normal form, the less redundancy is possible. So, and redundancy might contain inconsistent versions of the same fact. That's the problem. Well, no. This book contains, says no, but actually, well, actually, that's a direct question. All right, so all first normal form means is that there's a key. Oh, by the way, if something is in second normal form, then it's also in first normal form. If something is in third normal form, it's also in second normal form, and also it can go the other way also. For example, if you have something that's in first normal form, and the primary key is a single column and not a composite key, then it's automatically in second normal form. And if you have something in third normal form, and the primary key is a single composite, a single key, not a composite key, not a pair of columns that make up the key. If it's just a single column, and it's a third normal form, then it's also in B, C, and F. And those kinds of things also apply when we're in with the fourth and fifth also. And so if something is in if something is in third normal form, and it's not in B, C, and F, then that means that it has a composite primary key. And if it has a composite primary key, and you aren't gonna, you aren't gonna convert it into B, C, and F, then you're leaving open the possibility of some sort of redundancy, and so that's not good. So maybe the higher the key, maybe you should always strive for the highest normal form that you can. So anyway, so here, first normal form. Okay, so this is just an example. First normal form. So if it has a single, so if it has a key, so when you're creating a database in MySQL, you don't need to define a key. You don't need to say, okay, this column is going to be a key. And if you have a table in MySQL where no column is defined as the primary key, then you can have redundant rows in there. It's no problem. You can have a whole bunch of rows that are exactly the same. But usually you want to have, for any kind of database table to be useful, it has something that can at least be a key. It might not be defined as a key, but but if all of the columns together composite are required to be a primary key, then so be it. But still, you're not going to have any redundant rows. So column A depends on column B means that each value in B is related to at most one value in A. So if column A depends on column B, then each value of B is related to at most one value of A. Well, anyway, okay, so second normal form, for a table to be in second normal form, all non-key columns must depend on the entire primary key. Okay, so when you say the whole primary key, well, the only time that you must be how can you talk about not a whole primary key? Well, it must be that the primary key, well, so that implies that 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 you're talking about a composite key where you have some non-key value that's dependent on only part of the primary key. Okay, so this here happens to be an example of that. You have these are bookings. So bookings are passengers on flights. So we have, here's one booking is 222 in this flight, and there's another booking 222 same person in this flight, and another booking 222 same person in this flight, and another person 333 in this flight, which by the way happens to be the same as this flight, and so on. So but you need both the passenger number and the flight code together to uniquely identify the booking row. Okay. And so you have, but the problem is this table is not in second normal form because Elvira Yin here is not does not depend. Okay, the primary key for this table is this plus this, but the passenger name only depends on part of the primary key. It only depends on the passenger number part of the primary key. And so what you have to do is you have to take out the you have to remove the non-key value that's causing the problem. You take that out of this table. I mean, when you take the non-key value, you take passenger name out of this table, what do you end up with? You end up with this table over here, which now only has 4 columns. It doesn't have passenger name anymore. It only has 4 columns. And this has all the same information. But what do you do with the passenger name? Well, you make a second column, or you can make a second table, and for each of them, you add to that table the column which defined or determined the passenger name value, and so that is the passenger number. So this passenger table has the passenger name is over here, and as the primary key for this table, you have the passenger number. The passenger number determines the passenger name. The passenger name depends on the passenger number. So the key determines the non-key value. The non-key value is dependent upon the key value. All right, so this is how you take a table that's in first normal form but not second form, and turn it into a table that is turn it into second normal form. So you have the second normal form table here, and then you have this other table which is certainly in, you know, this is in the highest form there is. Just one key value and one non-key value. And this is BCNF. So anyway, so that's fine. This is so the passenger name depends on passenger number. Dependence on part of the primary key. That's so the repetition is Elvira and her passenger number and so on. Okay, and so here this tests your knowledge of second normal form. Here we have it just asks you the question, which fact is being repeated? Get the chat up here. And so that's easy to look. Well, it looks like it's John is, which fact is being repeated? John, student number John, student number John, student number John. The key in this table is student number and course code, but John, student number, a student number, student 8034, that student's email address is the redundant information. It's the repeated fact. So it's this one, the first one. And the non-key, what non-key column must be removed to achieve this second normal form? Well, that would be remove the email address, I'm thinking. A table with a simple primary key must be in what normal form? Must be in a table with a simple primary key must be in what normal form? With a simple. Okay, what they're saying is that so if you have a table that has if you have a table that has a primary key, then you know it's at least in first normal form. If uh, if uh, if that table if that primary key is a single value, a single column, then you know that there can't be any non-key values that are only dependent on part of the primary key, because you can't make part of the primary key because it's only a single value. So you know that if it's a simple primary key, you know that it's at least in second normal form or higher. So that would be the answer to that one. All right, so third normal form, here's where you could still have redundancies, but they don't have to do with non-key or there you can have non-key values dependent upon non-key values. Okay, so they don't have anything to do with the primary key. We've only been talking about things that are dependent on the primary key or part of the primary key, and now we're looking at just all non-key values. And so it turns out that with this database here, with this one here, we have the fact that that uh, that if you're in first class, your boarding zone number is always going to be 1. If you're in business class, your boarding zone number is always going to be 2. And if you're in economy class, your boarding zone number is always going to be 3. Okay, so the boarding zone number depends on the class. Okay, the class determines the boarding zone number. Well, here we're talking about two columns that don't have anything to do with the key. These two columns are the key. Okay, so what we got to do is we got to pull out again the dependent the dependent column, which is boarding zone number. We got to pull that out of this table, and so then we end up with just this column, and this column, which here we have that this column, and this column. And so this table is in third normal form because there's no non-key values dependent on any other non-key values. So then what do we do with the column we pulled out? Well, we made another table over here, and we put the column that the boarding zone number is dependent upon, and that's the key for this table. And so now we have this fare table over here, and we have this this other the booking table is over here. All right, so that's how you convert a table into a table that's in second normal form but not third normal form. You look at it, you say, aha, it's not in third normal form. We have this dependency here, so let's take that dependency out, make a table out of it, and now we just have this table here. So that's third normal form. All right, so and here you go through the test. Which fact is repeated? Well, it looks like, I see Kevin Durant twice, and that's the department chair of the MA department chair, math department, I guess. So that would be MA Kevin Durant. Which dependency violates third normal form? Well, if this is the primary key, then I guess the dependency is that the department chair name depends on the department code. Department chair name depends on department code. Yeah. Okay. Which column must be removed to achieve third normal form? Well, it would be the department chair name. You have to remove that one. You have to remove the. Okay. So with Boyce Cod, it's similar to the problem you have going from first normal form to second normal form. With a table that was not in second normal form meant that it had a non-key value that depended upon only part of the primary key. If you have a table that's in third normal form, but it's not in Boyce Codd, okay, again, you have it's a composite key. It's going to be a composite key, and also what it is you have um, part of the primary key is dependent upon a non-key value. So that's pretty tricky. So you have a non-key value determining part of the primary key. Meanwhile, you have this composite primary key that determines the non-key value that determines part of the primary key. And so I'm sure they have a nice example here. Let's see what that is. Okay. Anyway, there's the campus cuisine. Campus cuisine is an example of this. That's assignments. I think assignment 6 and assignment 7. That's farther along in the semester. But okay, so we have this case here where we have okay, here we talk about how we talk about candidate keys. Like if you have a database, if you have a table that's got an employee ID and a social security number, well, and the employee ID is the key, the primary key. Well, the social security number could be the primary key also. So it's a candidate key. Or you can have a candidate key be a pair of columns, and but still there's another key which is which we use as the primary key, which is only a single column. We do that pretty often too. And what is this? Okay, here's an example of that down here. But so for Boyce Codd, okay, a table is in third normal form if whenever a non-key column A depends on a column B, then B is unique. And that's sort of and if B is unique, then it's a candidate key. See. The definition of third normal form states that all non-key dependencies are on a unique column. And so, so it's on a candidate key. And Boyce, okay, so definition of third normal form applies to non-key columns only, okay, which allows for occasional redundancy. Boyce Codd normal form applies to all columns and eliminates this redundancy. So here we have let's say we have this employee project task table, which tracks assignments of employees to projects. Each project consists of many tasks. The company has 2 unusual business rules. Okay, each employee is assigned to at most 1 task on a project. Okay, so an employee is just assigned to 1 task. Okay, and so no task name. And so task name depends on employee and project name. Okay, so an employee can be assigned to more than 1 project, but for any particular project that an employee is assigned to, it's at most one task. So if you have the employee ID and you have the project name, then you can determine the task. If you have the employee ID and the project name, you can determine the task. Why? Because an employee is only going to be working on at most one task within a project. Now, a task name is used on at most one project. So that means, okay, so the task name, so there's a whole bunch of tasks that the company is working on, but they all have different names. Okay, each task name is used on at most one project. So for any task name, you know what the project is. Okay, because each task name is used on at most one project. So the task name determines the project name. Okay, the project name depends on the task name. So employee project task is in third normal form since the only non-key column, which is task name here, depends on the unique column, which is employee ID. Oh no, the task name depends on, the only non-key column depends on the unique column, which is the primary key. That's okay. So task name here depends on the primary key here, which is employee ID combined with project name. Okay. Now, however, this is not in voice code because project name depends on task name. So we have employee ID plus project name determines task name, but task name determines project name. Okay, so that just happens to be because of this. If we know the task name, well, we know the project name. Okay, so task name determines project name. So we have a case where task name depends on these two. However, project name, which is part of the primary key, depends on task name. So it's because of that dependency which makes this not in voice cod. Okay. Okay, it's in third normal form because any non-key value depends completely on the primary key. Yeah. All right. So what you do is you pull that fact out, and you create another table down here where you have task name, which determines project name, and then over here you simply have just task name, employee ID, and task. Oh, okay. So you don't need the project name anymore over here because this determines this. And you can recreate this employee project task table by just joining, just by doing an inner join. All of the task names match up with all these task names, so that brings the project on. So joining these two tables basically just attaches project name onto every one of these records. There. Okay, so here's a super key. So here's an example here of let's see how this one works. Refer to the following table. Assume all licenses and postal codes are in the United States. So employee ID is the only candidate key. Well, really, driver's license number is kind of intended to be to identify each individual person. It's one driver's license number per employee. Every employee has a driver's license, and no two employees have the same driver's license number if you include the state. Okay, so actually, this is the primary key for this table. But if you combine these two fields, that can also be a primary key. because we assume that in Illinois, that's going to be unique. In Texas, that's going to be unique. Now we also see they're clever here. They say, oh, in Florida, there's a same driver's license number. Well, the point they're making is that it's this combined with this, which can be a unique column or set of columns. Okay, so employees is false because that could be a key. All non-key columns depend only on unique columns. All non-key, okay, so the non-key columns is this one and this one. Those are the non-key columns. The rest of them are key columns because this together with this is a candidate key, and this is a candidate key, and this is a predicate key. So do all non-key columns depend only on unique columns? Yeah, I guess so. Yeah. The name, yeah. All non-key columns depend on unique columns. Yes, true. Yeah. Okay. Non-key means not contained in a candidate key. Okay. Employee is in third normal form. Is this in third normal form? I guess. Yes, all non-key columns depend only on unique columns. Okay, great. All columns depend only on unique columns? No. I bet not. All non-key columns depend on unique columns, but I don't think all columns depend on unique columns. No, because the postal code determines the state. The state depends on the postal code. So we have a postal code is determining. Okay, so we have a non-key value determining part of a candidate key, part of a primary key, candidate primary key. So that's just like up here where you have the project name is determined, or the task name determines the project name. The project name depends on the task name. Yeah. Okay. So so that would be so no, it's not in all columns. No, that's false. I think. Yes, it's correct. And so that means it is not in voice code. Is that true? It is in false. Yes. This is the repeat. So you want to remove the state from this table. The repeat is that you have, I guess you have this and this and this and this. That's the repeat. And so you want to take that out. This determines this. So you want to take this out and make another table with that information in it. But this is the primary key and this is the non-key, and that's another table. Meanwhile, we have these three, this, 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 and this as a key value. I mean, as a table. As a table in BCNF. Removing driver's license state from employee and create a new table containing postal code and driver's. This is wrong. This is wrong. This should be driver's license state. Okay. Anyway, question. Anyway, okay. So yes. All right. So so that's kind of all I had to. That's all I wanted to make sure I covered today. And chapter 3. is probably we're getting into some more important stuff regarding documentation. And so we're going to learn about entity relationship diagrams, and we're going to see how the normal forms and so on from the previous chapter kind of tie into this. And so that's pretty important. And then also back in normal forms, later on in the semester with assignment, actually I think assignment 2 has fourth and fifth, talks about fourth and fifth normal forms in there too. So I will come back to this and talk more about the redundancy and so on at that time. All right, so that's really all I have today. Does anybody have any questions? Okay, so I think I'll end it here today, and I will see you the next our next class is Friday at 11:30 a.m. Same place. Okay. So have a good week. Take care, everybody.